Right, we've got a worked example here for a parametric equations example, and this is to do with a curve is defined by the parametric equations x equals 1 plus 2t and y equals 1 minus 4t squared. So incidentally, I've drawn this here using Desmos. So this is how enter the parameters for parametric equation. Now that gives you a kind of a static picture, but it's actually quite useful to see what happens to which point you're drawing out as t varies. So what I've kind of I've done this sort of adaptive thing here with a as a slider, so we can see the value that we're tracing out. So as we increase the value of t, you can see actually that's the point that is being traced out. So that's t increasing that way. And if we go back there, this is t decreasing. This is negative t. So it's increasing more and more negative. So that's quite useful to see. Obviously, if you're doing an exam question, you're not going to be able to do that, are you? But I think it gives you a feel for, how these curves work. So for any one value of t, we can compute the x value and the y value and plot it on the graph. Okay, so that is that. Anyway, it goes on to ask us find dx dt and dy dt. We can easily do that. Obviously, we just have to differentiate these dx in terms of dt and dy in terms of t, and then y in terms of t, just using the power rule in each case. We get dx dt equals 2 and dy dt equals minus 8t. That's the derivative of that. And then hence find dy dx in terms of t. Well, here what we've done is this is where we're basically applying the chain rule. So we're expanding out this derivative into these two derivatives here, dy dt and dt dx. And dt dx is just the reciprocal of dx dt. So we can see we've got this thing here. If we were to cancel that, we would end up with dy dx. So that's how this works. Dy dt is this minus 8t, and that's dx dt, but obviously we're taking the reciprocal of it, so multiplying by 1 over 2, and so the dy dx in terms of t is minus 4t. It says find an equation of the normal to the curve at the point where t equals 1. Well, it's kind of ready-made here. If we substitute t equals 1 in here, then we're going to get the value of dy dx, that's the slope of the line, when t equals 1. So that's minus 4, and therefore the normal to the curve when y equals 1 is going to be 1 over the reciprocal of minus 4, and that's going to be a quarter. Okay, so that's that. And part C says find a Cartesian equation of the curve. Now the Cartesian basically is just y's and x's, and we've kind of factored t out of it. So all we're left with is something that represents the actual static picture on the curve, as we see here. There's kind of no evidence here. In fact, I'm drawing t equals 0 on here. There's no evidence of the time parameter on here. It's just x horizontal axis against y. So let's see how we do that. So we've got from this first equation x equals 1 plus 2t. We can rearrange that to give us 2t equals x minus 1. And then as a result, we square each side. We've got 4t squared equals x minus 1 squared. Okay, so then we can go to a y equation, and if we substitute this in for the 4t squared, we're going to get y equals 1 minus x minus 1 squared. And then we expand that, rearrange it, and we're going to get y equals 2x minus x squared, or y equals x into 2 minus x, if we like. That sort of tells us that it's going to cross the x-axis at 0 and 2. And so obviously this is a upside down quadratic, isn't it? That's what we've got with this. So that looks okay. Now, incidentally, with these questions, there is a temptation, I think, to try and get two equations explicit in T. So change these so we've got two equations explicit in T. I mean, you could do that. It wouldn't actually be too difficult here, but we don't really need to do that. What we're effectively doing is we're basically eliminating 4t squared. So if we can express these in a form that some function of y equals some function of t, and some function of x equals some function of t, which is the same as this function, then we can just crash the two functions of t together, and we come out with an equation in x and y. So that's more or less what we've done here. Okay, so that is that. It's a relatively straightforward one, but fairly typical actually of these kind of questions. Certainly find dy dx in terms of t and find a Cartesian equation of the curve. Those are two very common themes to these kind of questions. Okay, so that is it. I hope that has been useful. Thanks for listening.